This video, we're going to talk about images and preimages of sets. We'll go through the definition of what an image is, and I bet once we do that, the definition of a preimage is going to blow your mind. So, well, we've already talked about what images are, so that's not really going to be new. But just like before, going to give a formal definition to be very clear about this. I mentioned the book has images of elements and images of sets. I mostly have just been talking about images of sets. I don't find images of elements used very frequently, if at all, but this is where they finally start talking about the images of sets. So recall, so for some function that's going from A to B, let's say that C is a subset of A. C is a great choice of subset because C kind of looks like the subset sign. Anyway, C is a subset of the domain. Then the image of C under F. Let's write this a little different this time. We can also write it F of C. Before I wrote image of F. Sorry, image of C under F. But you can use different notation as well, trying to align with the book as much as I can. It's the set of all f of x. It's the set of all outputs such that the input is in that subset of the domain, right? That's the same C. That's a subset of the domain. And this makes a lot of sense when we look at this with a picture, okay? So let's say our domain is some set A, right? And we're looking at it as some subset of the domain C. Well, we also have a codomain over here, B. Again, we used to think of this as range. Now we're realizing range is something a little different. Well, the image is just where do all of those elements in C go to? So maybe the image looks like this or something. Who knows what the image looks like, right? But the idea is that the image is just, okay, if we take everything in C and apply F, the image is just the shape of what that looks like. All right. So it doesn't have to be the same shape. Shapes don't even really necessarily make sense in this context, but we can visualize it this way. Okay. Sometimes the image will behave very differently from the set that it comes from over here. But that's what images are. So what do you think? Preimages? Well, we're not getting there yet, but start thinking about it. We'll see if you're in for a surprise here. So let's do some examples with the image of a set. Let's look at the same function from before in 3.8. That function that went from 1 to 3 and then 1 to 5. And it looks something like this. This function before. The question is, I don't know if I called it H before, but it's H now. What is the image of the set 1 to 2? Well, remember the image of a set is a set of all the outputs that come from those inputs. So in other words, what we can do is we can look at the inputs from 1 to 3, say what outputs are covered in this subset of the domain. And here we can see that all the outputs from 1 to 5 are covered. That tells us that the image is actually the whole entire range, 1 to 5. Similarly, I could say, what's the image of 2 to 3? I'm going to write down the wrong answer here. This is the wrong answer. What's wrong with this answer? Why is this not correct? The image of 2 to 3 is 5. It's because images of sets are sets. So it's very close to being right, but it should be the set containing the number 5. Okay, so watch out for that. Images of sets are sets. And we could get as wacky as we wanted with all of this. We could say, what's the image of the set that goes from 1 to 1.5 union 2 to 3, right? We could write a set this way. And again, all right, this one gets a little harder to answer because we would have to find the function maybe or have a more accurate graph, but we could do this. Okay. But yeah, we could calculate the equation of the line that connects these 2 points and solve it this way. And then we'll also just union it with the element 5. So that's what we've got here. I lost my spot. One more thing. We've seen this before. But what is the image of the domain? That has a very special name. In general, not for this example, but in general, what's the image of the domain? It's called the range. So if the image of the domain is equal to the codomain, then we have a surjective function. All right, so let's go back to this picture that talked about what an image was, the image of a set. Well, what do you think the preimage of a set might refer to? Ready or not? Here we come. Let's see if you got it right. So we're going to have the same function. So we still have f that goes from a domain to a codomain. Now let's look at a subset of the codomain. Let's say D is some subset of the codomain. Then the preimage of f, sorry, the preimage, my notes are wrong. The preimage of D under f is written F inverse D. What do you think that's going to be in set notation? Well, let's actually jump around. Before we formally introduce this, let's go back to the picture. I want to make sure I use the same colors this time. Yeah, blue and green. All right, so again, we have some domain A, we have some codomain B, and now we're looking at a subset of the codomain. Let's say that we have some subset of the codomain. It could be any subset that we want. Let's call this subset D. Well, the preimage is just going backwards. It's just all the elements in A that went to that subset in D. So it's actually supposed to be the exact same picture. It's just backwards. Okay, so this is going to be the set. This is the preimage right here. This preimage is a set of all elements in A, so it's the set of all A in A, such that F of A is in D. Okay, so it's a very similar concept. The image of a set is all the outputs for all the inputs in that set. The preimage of an output set is all the inputs that took us there. Okay, so that's our definition for preimage. We'll do a couple examples, and then we will be done. So let's look at function t. Let's say little t is a real valued function. It goes from r to r, and it behaves with the rule that t of an input is that input squared minus 5 times that input. I want you to find the preimage of the set containing -1. So remember, that's going to be the set of all inputs that lead us to that set of outputs. So in other words, what are the inputs that give an output of -1? Well, you've done this in a pre-calculus class. Oops, I also wanted to adjust this. I wanted to change that to 0. Let's change the problem to the preimage of the set containing 0. So we'll just do it like this. We get x squared minus 5x. We know we can just factor that. We get x minus 5. We know the answers are going to be when x is 0 and x is equal to 5. So this preimage, be very careful, because our answer looks a little different than when you were in pre-calc. It's going to be the set containing 0 and 5. Okay, so the preimage of the set 0 equals the set with 0 and 5. And similarly, right, what is the image of the set containing 0 and 5? Well, that's 0. Okay, you see how this looks like inverse functions from pre-calculus. We'll more formally talk about inverses in future videos in this chapter. Okay, but that's basically it for that. Last example. Again, let's make things a little bit more interesting. And what's more interesting than our Cartesian product? So we have f that goes from z3 cross z4 all the way to z. So remember z3, we introduced that term earlier. That's the integers up to 2. You'd think it's the integers up to 3, but no, it's the integers up to 2. And similarly with z4, right? And it's used in modulo arithmetic a lot, which we're not really going to spend too much time on. And let's say that the rule here is that f of a comma b is just a plus b. All right. So my question for you is find f inverse, find the preimage of the set containing 3. And then I want you to answer, is f surjective? Then finally, I want you to tell me whether f is injective as well. So pause the video, answer these questions, and let's see what you've got. So I'm going to define this first question. This helps me sometimes. So I'm going to introduce it to see if it's an option that helps you as well. This is going to be the set of all inputs, and our inputs are a comma b, right? This is going to be the set of all inputs in our domain, which is z3 cross z4, such that f of the input equals that. So it means a plus b equals 3. So I actually feel like I should have added a mod here. Oh, it's fine. Okay, so that is what the preimage of 3 means. It's the set of all the inputs that go to 3. And going to 3 means this is the case. So let's just look. And again, it might also help if you write down what Z4 is as well. You can always take as many steps as you need to make things make a little bit more sense. So 0 could go with 3. That adds to 3. 0 doesn't add to anything else. 1 could go with 2. Nothing else to add to. 2 could go to 1. Or 3 can go, whoop. Uh-oh, what's wrong with this? Right? 3 is not in Z3, regardless of what you might think. All right, so that doesn't work. We all have all the flips as well. Okay, so we have 3 comma 0. We have 2 comma 1. We have 1. Oh, wait, we already wrote 2 comma 1. Ew. Okay, so we don't have, all right, this is a nightmare. All right, so this should be it, unless my brain is completely fried. All right, so we have these 3 elements that are going to get us there. So is this function surjective? Kind of unrelated to the previous question. Does this function go to every integer? If we look at all the outputs, if we look at the range of this function, if we look at the image of the codomain, do we get every integer? I don't think so. Not with just Z3 and Z4. This is no way. Not even close to being surjective. Is it injective? Is there an output? Sometimes it's maybe easier to answer if it's not injective. It's not injective if there's an output that we can get with multiple inputs. Oh. Uh-oh. Clearly it's not injective, right? We just showed 3 different inputs that go to the same output. This is not one-to-one. So again, You could say letter A proves that it's not injective. All right. So that's kind of an exploration of these definitions and some practice with this. And that's it for this video. We got injective, surjective. We'll talk about bijective coming up. You will not want to miss it. So take it easy. Let me know if you have any questions.